Okay, so this begins the second part of the video on Chapter 3. So we've been dealing with right triangles. We're going to continue with right triangles. So far, we've only talked about solving for their side lengths by using Pythagorean theorem, and also by using the converse of it to determine whether you have an acute or an obtuse triangle. So now we're going to talk about how we can solve for all sides and all angles using something called SOHCAHTOA. So SOHCAHTOA is how you remember the trigonomic relationships in right triangles. So, and I prefer to write it like this. So instead of writing it the way it is here, which looks very, which looks very pretty, I would tell you to write it like this. The sine of an angle equals opposite over hypotenuse. The sine equals that ratio. Cosine of an angle equals the adjacent over the hypotenuse. Cosine equals that ratio. The tan of an angle equals opposite over adjacent. Okay, so those are the relationships, and they're spelled out here for us. So we want to practice a couple of these. So there are actually 6 relationships. So the sine, cosine, and tan, which we're going to really emphasize. And then there is cosecant, secant, and cotan. So the reciprocal of sine is cosecant. Okay, so CSC of an angle is the cosecant of an angle. Okay, and they're reciprocal. So notice, if the sine of an angle equals opposite over hypotenuse, its reciprocal cosecant equals hypotenuse over opposite. Then you move on to cosine. The cosine of an angle equals adjacent over hypotenuse. Its reciprocal is SEC, so SEC of an angle is the secant of an angle. And it's the reciprocal because it equals hypotenuse over adjacent. It's the flip of what cosine is. And you can probably guess that cotan is abbreviated COT. So this is cotan of an angle equals cotangent of an angle, and it is the reciprocal of the tan. Okay, when we do this section, your mode will be in degrees. Okay, and I'm going to just say in passing, if we want to get an angle, we're going to use something called inverse trig. Okay, there is an activity posted which you are to do. I also posted the answer key with it. So that's going to be a good review. We are going to do a couple of slides right now practicing this together. Okay, so on the next slide we will do that. Okay, so in this slide I have a triangle. It's a right triangle. I give you the fact that the angle in the top, the B angle, is 40 degrees. And I'm going to say I would like you to solve for x. Okay, so solving for x from the acute angle's perspective. For SOHCAHTOA, you're always going to use the acute angles. You're not going to use the 90-degree angle. So from that acute angle's perspective, standing there, I have the adjacent, which is right here next to it, and I need the hypotenuse. Remember, the hypotenuse is always across from the right angle. So adjacent over hypotenuse, adjacent and hypotenuse. I have that combo for cosine. So now I'm going to set up my equation. The cosine of 40 degrees equals adjacent, which is 12, over some missing hypotenuse. So do your cross products because this really is fraction equal to fraction. Okay, so x times the cosine of 40 equals 12. My goal is to get x by itself. Divide by cosine 40. Divide by cosine of 40. Okay, so x will equal 12 over the cosine of 40. Okay, when you start typing in cosine, you're going to get an open paren. Close the paren every time. It's going to be important when you least expect it to be, so just have that be your habit. So first off, grab your graphing calculator, go to mode. Make sure that you are in degrees. Okay? So now once I see I'm in degrees, because remember the default is going to be radians, and we're not using radians right now. So second quit out of your mode and say 12 divided by cosine. You see where the cos symbol sign is? It's it's 2 rows above the numbers. So 12 divided by cosine of 40 degrees, close my parenthesis, equals, and round it to the nearest tenth for our purposes here. So I'm going to get x equals 15.7. Okay? So let's continue this work on this problem. I'm going to say instead of just get x, why don't we also get, and I'm going to call this y. Okay? So we're going to solve for all the missing sides. So at this point, we have some options. We could use Pythagorean theorem, since I now know that my x, so I'll change that back to my pink, my x equaled 15.7, so I could say, using Pythagorean theorem, 15.7 squared equals, okay, that's the c squared, 12 squared plus y squared. Okay, so let's go through this exercise. So what is y going to be? So without grabbing my calculator yet, I have 15.7 squared minus 12 squared equals y squared. So therefore y is going to be the square root of 15.7 squared minus 12 squared. Put that in your graphing calculator in that one step. Second square root of 15.7 squared minus 12 squared. Close the parentheses again. Hit enter. And I am getting that y equals 10.1. Okay, so y equals 10.1. What if I did not want to do Pythagorean theorem, which was here? Okay, so that was Pythagorean theorem, a squared plus b squared equals c squared, or in our case, c squared equals a squared plus b squared. What if I just love my trig and I wanted to practice it one more time? So I'm just going to raise SOHCAHTOA up here so I have some place to work. And I'm going to rewrite that, though, because that's going to be important. So we're going to squeeze it in down here. So here's SOHCAHTOA. Okay, so let's say that I want to find y. And all I have so far is the 12. Okay, let's just say I haven't even dealt with finding the x yet. I'm going for the y. So what I'm looking at is from the 40-degree perspective, y is opposite, okay, and 12 is adjacent. Opposite, adjacent, tan. The tan of 40 degrees equals opposite, which is the y, making believe we haven't solved for it yet, over the adjacent, which is the 12. So you're going to do your cross products. 12 times the tan of 40 degrees, close your paren, equals, when I do that math, I get y equals 10.1. Okay, let's take this one step further. What if I said I wanted you to find every missing side and every angle? So in this situation, because I have the 90 and I have the 40, and I know that you have to have 180 degrees in the triangle just by doing subtraction, I can state that the other angle is 50 degrees. And I have completely solved this triangle. Okay? So that was using SOHCAHTOA to get missing sides and subtraction to get a missing angle. Okay, we're going to do one more of these, and we're going to use SOHCAHTOA to find a missing angle, and I'll show you how to do that. Okay, so in this screen, we are looking for the missing angle theta. Okay, that's called theta. So I look at the world from theta's perspective. And from theta's perspective, what I see is that I have adjacent and I have hypotenuse, because hypotenuse is always across from the 90 degree. Adjacent and hypotenuse is cosine. So what I know is that the cosine of this mystery theta equals adjacent over hypotenuse. All right. When you want an angle, and I want an angle, you're going to use inverse trig. Okay, so to get the angle by itself, you are going to multiply this side by cosine of -1, and this times the cosine of the -1. That cancels the word cosine, and it leaves us with theta equals cosine the -1 power of 12/15. Okay, this is inverse trig. You always use inverse trig used to get angles. Okay, when you run an angle, you're going to use inverse trig. So grab your graphing calculator, and you're going to notice that above the sine, cosine, and tan keys is sine to the -1, cosine to the -1, and tan to the -1. Those are your inverse keys. Those are your angle getting keys. So say second cosine to the -1 of the fraction 12 divided by 15, close your paren, and I am finding that my angle equals, rounding to the nearest tenth, 36.9 degrees. Okay, so this angle is 36.9 degrees. Then by subtraction, you can figure out the other acute angle is going to be 53.1 degrees. Can you get the missing side? So let's use trig to get the missing side. So I'd like to have this missing side. So from the angle I found, from its perspective, I want the opposite, and let's say for our sake, we have the adjacent. We can also use the hypotenuse, but I'm going to do opposite and adjacent. That's going to be tan. So I can say that the tan of, I know the angle is 36.9, that equals x over 12, opposite over adjacent. So to get your value for x, you say 12 times the tan of 36.9, close your parens, and you get, rounding to the nearest tenth, 9.0. And so if I asked you to find all the missing angles and sides for this particular triangle, we can do it. I've also showed you how to use inverse trig to get your angle back. Again, all these angles are in degrees. So now we're going to talk about what happens if you don't have a right triangle. How can I solve for missing sides and for missing angles? And that's going to be the law of sines and the law of cosines. So let's do that next. Okay, so if you have any kind of triangle, it could be a right triangle, it could be a non-right triangle. You can use law of sines if you have a pair. What does that mean? A pair means that you have an angle and its side. You just need one of them. As long as you have one of those, so an angle value and a side value, you can use these proportions. You only need to use two at a time. Okay, so let's look at our example here. So I see that in this situation, so I'm going to change my color, I indeed have a pair. I have an angle and a side. So I'm going to use the law of sines to solve for the missing side. So I'm going to say, setting it up, the sine of an angle, the angle is 48, over 28 equals the sine has to be followed by an angle, 35 over x. So we're going to do our cross products. So that's going to give us x times the sine of 48 equals 28 times the sine of 35. Divide both sides by the sine of 48. Plug that in your graphing calculator. So I'm going to say 28 times the sine of 35 divided by the sine of 48, close parenthesis, and I'm going to get an x value, x equals 21.6. So remember, when you're trying to get a side, you're going to use straight up sine. When looking for an angle, you'll end up using inverse. We're not looking for an angle here, we're looking for a side. So for this triangle, you also could have found the missing angle, but just by using subtraction. Okay, you could have said 180 minus 35 minus 48. 180 minus 35 minus 48, and you would have gotten a top angle. This top angle would be 97 degrees had I asked you to solve for the triangle. Okay, so that's an example of law of sines. I'm going to show you law of cosines, which you use for non-right triangles, or right triangles if you want. When you do not have a pair, a matching pair, then you have another option. It's called law of cosines. We'll do that in the next slide. Okay, so here's law of cosines. And as I said, you use that when you don't have a pair, which means an angle and the side opposite it. So I do not have a pair in my yellow triangle that I've written here. So things to note. Law of cosines is certainly more complicated, but it's just a question of plugging in. So if you want to figure out a missing side, you're going to use this version of law of sines. If instead you want to figure out a missing angle, you're going to use this version. So I have this triangle. I've labeled it so that I can solve for missing side little c, okay, which is the x. So how do I set this up? So I'm going to say I'm going to use this version, and my setup is as follows. C squared, because it's small letters, that's going to be the side, okay? So this equals the c. So I'm going to say c squared equals a squared is going to be 29 squared plus b squared is 34 squared minus 2 times a times b times the cosine of c. It is critically important that you put this in as one equation. If you try doing it in parts, you will get it wrong. So first I'm going to find c squared, which is really x squared. I will eventually have to take the square root of it. But right now I'm going to say 29 squared plus 34 squared minus 2 times 29 times 34 times the cosine of 111, close paren, equals 2703.7. Do nothing with that. Say second square root of your answer, and you get 52.0. Okay, so what I found is that C equals 52.0. Okay, so in this slide, we're going to use law of cosines again, but this time we're going to be looking for an angle. So I wrote angle here, and I added the word side to the other one. So I've drawn this triangle in yellow, and we're going to try to find angle X. So here's angle X, and I've labeled my triangle with ABC, and I've circled in yellow the version of the law of cosines that I'm going to need to use. Okay, you're going to have to be able to figure this piece out yourself when you set up your triangles. But this right here is a maze worksheet, which is going to help you work on this. I have posted this on Joule along with the answer key. So let's set this up now. So I'm going to say the cosine of A, knowing that A is really X. So the cosine of A equals B squared. So that's the little side. So 28 squared plus C squared, which is 26 squared, minus A squared. And A squared is 30 squared over 2BC. So 2 times 28 times C is 26. So in your graphing calculator, you're going to put that fraction, and then you're going to use inverse cosine of the answer. So using your calculator carefully, if you have to use parens, do that. I have 28 squared plus 26 squared minus 30 squared divided by 2 times 28 times 26. Okay, so I get 0.4. So once I get an answer, so far I have cosine of A equals 0.4 plus additional decimals. So in my calculator, I'm not going to write that down. I'm now going to say second cosine negative 1 of second answer, because there's more decimal points than just the 1. And I'm getting an angle of 67.4 degrees. So X equals 67.4 degrees. So that's how you use the law of cosines to find your missing angle. Okay, I would highly recommend you go through this maze worksheet and get comfortable using these equations. I will always give you the equations. You need to know how to manipulate them. Okay, I'll give you the versions for both sides like this and angles like this, and you'll have to know how to manipulate them. Okay, we're going to go on to something else in 3-4 on the next slide. Okay, this is a continuation of the similarity discussion that they pick up again in 3-4. So I'm just going to talk through this because it's pretty self-explanatory. So the area and the perimeter of similar figures can be obtained if you know the scale factor. So if you have two polygons, so they can be any shape, they can be a triangle, a quadrilateral, a hexagon, an octagon, it doesn't matter. If you know they're similar and you have their scale factor, which is the length of a corresponding side in one of them over the length of the corresponding side in the other shape, then the perimeter will also be, okay, so the perimeter is also going to be in that same ratio, okay? So that will also have the exact same scale factor, just like the altitudes had the same scale factor. The area, however, will not have the same scale factor. The areas will be related by the square of the scale factor. So, for example, let's say that my scale factor was 1 to 2, okay? And say that the perimeter of the first one, okay, so 1 to 2 is G2 over G1. Okay, so the perimeter of the second one is unknown, but the perimeter of the first one, let's say, is 20. Okay, so do your cross products. 1 times 20 equals 2 times something else. So the perimeter of P2 has to be 10 because it has the same scale factor. Okay, the area, however, does not have the same scale factor. So you're going to take your scale factor and you're going to square it. So if you have the area of 1, so you're looking for area 2, and let's say area of 1 is, I don't know, if that's 20, let's just say the area of 1 is 40. Okay, so 1 over 4, this is going to be. So 1 over 4, once you square it, equals A2 over 40. So it looks to me like A2 has to have an area of 10 because its scale factor is going to be the squared scale factor of the original proportions. Okay, so that's the big takeaway from 3-4. Okay, nothing major, but an important concept because it makes your math easier if you know those relationships. You can get an answer very quickly without having to try to solve for all the missing sides and then determine either the perimeter or the area. Okay, we're going to talk about dilations in the next slide. Okay, dilations is a whole topic in itself. So instead of me trying to teach this in a slide, I have 2 different resources for you. Okay, I would recommend, and I put both of these on Joule, that you watch the YouTube first, and then that you try to work through this worksheet, and knowing that I have given you a lot of detail in that worksheet. Okay, the worksheet itself has a whole explanation about dilations. So dilations are basically taking one figure and making another figure that is similar to it by either enlarging it or shrinking it. Okay, dilating could be either enlarging it or shrinking it. So in this example right here, you take the ABC triangle and you dilate it as a bigger triangle, and they tell you what ratio you're going to do that with. Okay, so here's your bigger triangle, and you're going to be doing it on a coordinate grid. So there is great detail in the YouTube. It is very well done. I want you to look at that and learn from it. And then also I would print out and go through the Math Bits notebook on dilations, and you will feel very well versed in dilations. Okay, we have one more slide, and we'll do that next. Okay, so this last slide is about similarity again, and similarity is for more general figures. So it says you can use the scale factor here as well. So they give you the scale factor, you have a lot of information. So volume and surface area can also be discussed. We so far discussed perimeter and plain old area. So here's a situation where you have 3-dimensional figures. So that's the more general figure. So if you know that figure T1 is similar to figure T2, and the scale factor is S, then you know that the distance between the points in this particular set is always going to have that scale difference. If you are talking about the surface area, that's not going to be the surface area from T1 to T2 is not going to be in the scale factor. It's going to be in the squared scale factor. It's squared because surface area is squared, just like regular area is squared. That's why it's squared. What about volume? Volume is given to me in cubic units, and therefore you can probably guess that the scale factor will be cubed between 2 figures that you know are similar. Okay, so that's really the end of our discussion, and you have a lot of things to go over that are posted for you on Joule.